This is the first page of the PowerPoint that I go over with students in the lesson Graphing Exponential Functions. I emphasize the vocabulary and give them a few minutes to write out, paraphrase in their own words. They may have to do some of it for homework if they don't finish, or draw pictures of so they'll remember what the vocabulary is. We previously have studied domain, range, x-intercept, y-intercept. I'll briefly review it with them if they have questions or have problems writing it out. Continuous, does it have any holes in it? Can you draw the line without lifting your pencil? And it has arrows on the end to show it continuously keeps going. Equation of the horizontal asymptote and shifts I'll concentrate a lot in this lesson because it's something we previously have not discussed. Percent of increase or growth is in all of these problems because that b value is greater than 1. It's actually 2, which is 200%, and it's doubling, just like the penny problem we previously did in this unit. And then we had looked at the warm-up y equals 2 to the x. Well, what happens when you add that negative in front on the first graph? Well, it's just going to make it reflect over the x-axis. That horizontal asymptote we talked about, that the graph is approaching but not crossing, that plus c value out here, if there were a constant, that would be the horizontal asymptote. But in all these problems, in all 4 of them, it's basically just plus 0. There's no vertical shift being added to any of these functions. There's just some shifts on the inside of the function on the bottom 2 graphs. So the horizontal asymptote on all of these 4 graphs will be y equals 0, or the x-axis that the graph will approach but not cross. So we'll go ahead and put those in. They're all going to have a horizontal asymptote of y equals 0. And then we'll talk about, well, what else is happening in the equation to make it different than the original graph y equals 2 to the x. Well, the negative in front is going to make it just reflect over the x-axis, because when you put in 2 to the 0 power, you still get that key point. Instead of 0, 1, 2 to the 0 power is still 1, but you add that negative in front and you get 0, negative 1. And then you'll get, when you put 1 in, 2 to the first is 2, but you add the negative, you get negative 2, and then negative 4, and then it just approaches that horizontal asymptote but doesn't cross. The next one, the negative is in the exponent, and so 0 is never negative, so that key point is still going to be 0, 1, but now as x increases, when you put in 1, that's 2 to the negative 1, the y values actually decrease, and when you put in negative 1, the smaller the values for x, the y is going to increase, because that makes it a negative 1 makes it a positive 1, which is 2. And so now it's going to decrease from left to right. Just draw it in there. So as the x values increase, the y values are decreasing. Y equals 2 to the x minus 1 is inside the function. It's basically a shift to the right. And you could do a t-table to see that. So if you put in 2 to the 0 power, that's going to be 1. But if you put in 2 to the 0, that's 0 minus 1 is 2 to the negative 1 is 1/2. Everything is actually shifted 1 to the right. So that key point 0, 1 has shifted 1 to the right. So now it's 1, 1, because if you substitute 1 in for x, that's 2 to the 0 power. And so the next one over would have went to 4, and then it's approaching that x-axis. And then now x plus 1 means it's going to shift 1 to the left. And so now that 0, 1 is going to shift at negative 1. It's going to go to 1. And then at 0, it would have been to 2. And so on. And so now it's just shifted, but it's still increasing from left to right.